We are studying ocean currents. Today, let us study the ocean currents of Atlantic Ocean. As you know that Atlantic Ocean is the second largest water body on our planet Earth. It is named after this Atlas mountain located to the northwest of Africa continent. To the east of Atlantic Ocean, it is Europe and Africa continent. To its west, North America and South America continents, and in the north, Atlantic Ocean is bound by Arctic Circle, to the north of which it is Arctic Ocean, and in south it is Antarctic Circle, to the south of which it is Southern Oceans. Now let us study the currents of Atlantic Ocean. As you know that Atlantic Ocean is least affected by tsunami because earthquakes rarely occur in it, while Pacific is largely and frequently affected by tsunami. And this Atlantic Ocean is largely affected by currents and waves. And to begin with the study of currents of Atlantic Ocean, let us begin from North Atlantic Ocean, and that too with here North Atlantic Equatorial Current that flows parallel to the equator in its north, and it starts from Guinea coast and collides here on the northeastern coast of South America. It is warm water current, and its main cause is trade wind, which blows from northeast to southwest direction in north hemisphere, and that trade wind drags water westward. This water comes here and collides with the northeastern part of Brazil coast and Guyana, and its impact on it. But impact is minimum because these are the tropical countries, and this current is also warm, hence there is a least impact. But as this current moves parallel to the north coast of South America, it is here moving westward along the coast of Venezuela. It is also termed Venezuela current, and it comes here in the Caribbean Sea and on the basis of Carib countries and island it is named. And as it passes through Caribbean Sea here between Yucatan Peninsula and this Cuba island, here it is Yucatan Strait, and through this strait this stream passes, hence it is called Yucatan Channel, and then it enters the Mexico Gulf, and here it is Florida Peninsula and Bahama Islands, and as it passes through the south of Florida, it is called Florida Current and Bahamas Current. It carries the fresh water of Mexico Gulf, and it moves along the coastline, not controlled by wind, rather controlled and directed by coast. It moves parallel to the east coast of North America, where it is called Gulf Stream because it is coming from Mexico Gulf, and it moves in northeastward direction. But there may be a doubt that whether it is driven by wind or it is controlled by the direction of coast. So the second option is correct, and this Gulf Stream is controlled by the east coast of North America. It has impact on the east coast of North America during especially winter seasons because At the advent of winter, this area falls under the grip of cold polar waves. And because this is warm water current coming from south carrying relatively warm water, that's why this Gulf Stream keeps the temperature of eastern coastal plain of USA and Canada relatively warmer. It comes near Newfoundland and here confronts this Labrador cold water current. Here it is Labrador Peninsula of Canada, and on the basis of this, the cold current coming from north or say Arctic Ocean and carrying icebergs and cold water comes here through this Labrador Strait, Davis Strait. Hence, it is called Labrador Cold Current. Now here, there is very wonderful oceanographic or oceanic phenomena, collision between warm Gulf current and cold Labrador current. Certainly, the level of water of ocean of which will be higher, it is very easy to answer. The water level of this Labrador current will be relatively higher than that of Gulf Stream because of cold water, and secondly, the height of icebergs is above the sea level. That's why where two different nature currents meet in water body or in ocean, phytoplanktons are found, and due to phytoplankton, zooplanktons are also found in abundance, and fish are found in large quantity and of different species. At the same time, here, due to collision of two currents, their water eddies are developed, which move northeastward due to the impact of here western winds. But here, this is oceanic phenomena. Now let us study the atmospheric condition here near Newfoundland. In atmosphere, two different nature winds, cold from north, which is polar, and warm from south, which is westerlies, meet together, develop cyclone, and there is a thermal inversion. There is a development of cold and warm front in which thermal inversion is found, and due to thermal inversion, here fog develops, and fog in atmosphere, fish in ocean. These are the two very important phenomena, salient oceanic and atmospheric features found here. Due to it, as you know that here the water is shallow due to presence of two banks, Grand Bank and George Bank. What is bank? Bank means the oceanic water which is shallow. Why it is shallow? You have studied in plate tectonic geomorphology that the northeastern part of United States is rising. You have studied that the Newfoundland and the Appalachian are rising. It means to the west of mid-Atlantic ridge, this part is rising, and this rising part having shallow water is called Grand Bank and George Bank. It is of world fame for fisheries, fishing. Why? Because water is shallow and insolation is sufficient. Phytoplanktons, due to meeting of cold and warm current, is found, but in atmosphere fog is found. Fog is not related with fish because there was once a question that here fog is found, fish is found. Both are correct, but both are not interrelated. Now, after concentration and giving birth to fishing ground. Here, what becomes of the excessive water? It has two directions. One, water subsides here. It is raised due to collision of the two. With the result, it subsides and there is a subsurface ocean current flowing just below the Gulf Stream, which is called Black Scarp Current, because here along the east coast of North America there is a geological feature named Black Escarpment. On the basis of that, it is called Black Current. Now, second way is that this excessive water moves in northeast direction driven by the westerlies, and it has two paths, one moving to the south, one moving north, and the southern one reaches here to the south of here United Kingdom, and the northern branch passes through the north track, which passes through the north of United Kingdom, and both here meet in the North Sea. As you know that this North Sea has relatively cold water, and this warm water of North Atlantic drift. This is drift. This is not called current, because currents generally move along the coast, while drift in open seas driven by only wind, and this is westerly wind. That's why called North Atlantic drift. And this carries warm water relative to that in North Sea. And when this warm water and North Sea cold water meet, here again fish are found. And here it is also shallow water of North Sea, because as this oceanic water near Labrador is shallow, in the same way this water of North Sea is also shallow. Why? Because we have studied it in tectonics and in endogenic forces, that if the eastern part of North America is rising, which are recorded here in Newfoundland and a place here. Likewise, here this part is also rising, which are being noticed in the rising of Scandinavia and Norway and Finland, and the area of these countries are increasing because land is rising and opening. That is different thing. But here we have to study that here on the west of Europe in North Sea there is a bank called Dogger Bank, which is world famous for fishing. Now its cause we have studied. Second very important point is that what impact this North Atlantic drift will have on the west coast of Europe. Certainly during winters, when sun shines vertical over Tropic of Capricorn in the month of December, the cold polar wind take the entire North Europe under their grip, and this warm water current shapes this West European coastal countries from severe cold, and that's why this North Atlantic drift is called blanket of West Europe. Now it proceeds northward, and here it is called West European current, again moving toward north, carrying warm water to the north coast of this Scandinavia. This is called Norwegian current, and this keeps the north coast of Europe water warmer. Here there is one port, Murmansk port. This is located on 66 and 30 degree north latitude, means just on Arctic Circle, which should be frozen during winter here in the month of December when sun is vertical here. But this Norwegian current warm water keeps it warmer throughout year, hence it is called all-weather port. Now, after understanding the mechanism of North Atlantic drift, its impact on fishing industry here, and on port, which may be asked separately that what are the causes and impacts of the North Atlantic current on the economy of Western Europe. So you should be ready to give answer scientifically. Now come here. This is Iceland. To its east it is called Irmingar Current, and to its west it is called East Greenland Current. East Greenland is a cold current which resembles in nature velocity characteristics with that of this Labrador cold current, while this Irmingar current is warm current. That's why the Iceland's southern part is relatively warmer, and this is the region that most of the population of Iceland and its capital located found along the southern coast of Iceland. Now, this North Atlantic drift collides with here this peninsula of France and Spain. After collision, its one branch moves north, and through here English Channel it reaches North Sea, while one branch turns south and moves through the front of Gibraltar Strait and Morocco. Here there is one island named Canary, because this water is moving from north to south along Canary, hence it is called Canary Current, which is cold. Here again one doubt may be there in your mind that suppose its temperature is 25 degree Celsius, but while moving north it is called warm current, because in relation to these countries their atmospheric condition it is warmer, and the same temperature water current having 25 degrees Celsius, if moves south, named as Canary Current, it is called cold water current. Why? Because people living here in Morocco or northwest African desert region have warm atmosphere. In comparison to that, this current is cooler, hence it is called Canary Current, which is cold and which keeps the coastal climate of northwest Africa cooler. And this Canary Current reaches here near the Guinea coast. Along Guinea coast, it flows along the coast of Guinea, which is called Guinea Current. This is also cooler, cold current, and its some water follows the North Atlantic Equatorial Current, and gradually as it comes southward, although this is called cold Canary Current, but gradually with the movement towards equatorial tropical climatic region, this slowly becomes warmer, and then this water flows in the form of North Atlantic Current. It becomes completely warmer. Thus, this is a current. This is a current of North Atlantic Ocean. In this system, we have seen that this is the North Atlantic Equatorial Current, then Yucatan Channel, Florida Current, Gulf Stream, and here North Atlantic Drift, and again Canary Current. Thus, a cycle of current is being developed, and this cycle encircles this water, which is relatively saline and warmer. It is called gyre, and it is also called gyral, which in North Hemisphere it is subtropical gyre, which moves in clockwise direction. And as we will study that these gyres are controlled by here the wind system, and gyres turn a little bit right to the wind system, and due to rotation of the earth, these gyres shift or tend westward. It means this gyre will get west side, and in the east side there will be upwelling that will be studied separately. Here one more oceanic phenomena is that this is called Sargasso Sea, because this is characterized with a grass algae named Sargasso or Sargassum, and this is a saline water called salina, because the salinity along the east coast, along here west coast, and here in equatorial region will be less. Here salinity will be less. This is salina having this Sargassum grass, and this Sargasso Sea is sometimes termed that sea without coast. All the oceans, all the seas have coastline of land, but this Sargasso Sea is without coast. It is surrounded by the current from all sides. Now, one very important thing here in north, means in subpolar belt, is this Irmingal current reaches in Arctic Sea, Arctic Ocean. From Arctic Ocean, this East Greenland current moves south, and then this water through North Atlantic Drift again reaches in the form of Irmingal current to Arctic Sea. Thus, a cell or cycle of current is being developed here, which develops a gyre or gyral of North Atlantic subpolar gyre. It is called North Atlantic subpolar gyre, which is moving in anti-clockwise direction, while subtropical gyre direction is in North Hemisphere is clockwise. Now, let us come to the current of South Atlantic Ocean. Here, this is South Atlantic Ocean current, which is warm, and the cause of which is South Hemisphere trade, the direction of which is from southeast to northwest. This south trade drags the South Atlantic Ocean water, which is forced to move from east to west. Hence, it is called South Atlantic Equatorial Current. This water comes here along the east coast of Brazil and collides here. Very noteworthy phenomena here is that at the mouth of Amazon, here there is North Atlantic Equatorial Current carrying voluminous amount of water. At the same time, river Amazon, the largest drainage basin of world, carrying water, pours down water here, and that's why here there is an abundance of water which is deflected to the north and some water to the south, and that's why there is a vast tract of flood at the mouth of river Amazon, and this is the reason that Amazon is a river having the widest mouth in world. Now, after the collision of North Atlantic Equatorial Current and South Atlantic Equatorial Current along the east coast of Brazil, there is a excessive water, some part of which turns back and it moves from west to east parallel to the equator, which is called counter equatorial Atlantic current. And this is warm water current which joins here the south equatorial Atlantic current and then Guinea and north equatorial Atlantic current. The southern branch of this south equatorial Atlantic current flows along the coast of Brazil and Argentina, which is called Brazil current, and this is warm water current, while it confronts with this Falkland current, which is cold water current. This Falkland current is a branch of Circum-Antarctica polar cold current, and this carries icebergs and cold water. The same happens here, which happened here near Newfoundland. Means here there is a meeting of warm and cold water, hence in atmosphere fog, in ocean phytozooplankton, and here fish develop in large quantity, and the economy of this Falkland and South Argentina depends on this fish resource. Now after the meeting of these two, the water which is in excess flows along this Antarctica circumpolar current, which is of cold nature, and when it reaches here, it is divided in two branches. One branch moves to north, which is called Benguela current, not Venezuela. Venezuela current is here, and here it is Benguela, that is a city, port in Angola, and it is on the coast, hence Benguela current is named after this port city, and this is cold water current, and it is moving parallel to the west coast of Africa. And here you know that there is one desert, Namib, here one desert, Kalahari, and these two deserts are warm desert because these are located on Capricorn. And but when this Benguela current flows parallel to these deserts, this is cold water, and these deserts on the basis of that are called cold water desert. So this is cold water desert, means Kalahari and Namib. This Sahara or Western Sahara is also cold water desert because this Canary current is cold current. Here there is a Sonoran desert. This is hot desert, but to its west it is California cold current in Pacific Ocean. Hence this Sonoran desert is also called cold water desert. Here it is Atacama desert, and to its west here it is Humboldt or Peru cold current. Hence it is also called cold water desert. In the same way, there are 4 cold water deserts, 1, 2, 3, 4, and these also witness the upwelling phenomena. Here is upwelling, here is upwelling, here also upwelling, here also upwelling. Why upwelling? It will be detailed. It will be discussed in detail while studying upwelling. But here, one again cold desert is found in Australia. To the west of Australia, as we have studied that there is a west, as we will study that there is a West Australian cold current. That's why Western Australia desert is also cold water desert, which is the fifth. 1, 2, 3, 4, and that is fifth. And this is a cold water current which slowly and slowly moves north, and relatively its water becomes warmer and then it flows. Thus, just behind this South Atlantic Equatorial current. Thus, there is one system of currents in South Atlantic Ocean. Here, one thing more is that here this Antarctica cold current flows to the east and enters the Indian Ocean, and here it is called Agulhas current, named after Agulhas Cape. Here is a meteor seamount and other oceanic topography which are relatively high and divide this current in two parts. One, this Vengula current, and second, this Agulhas current. And this is one gyre developed in South Atlantic Ocean, and this is called subtropical gyre or gyral, which moves in anti-clockwise direction. There is no subpolar gyre in South Hemisphere. Why? We have already discussed it, that in South Hemisphere it is ocean hemisphere and there is a least impact of trades and land barriers, and the southern western wind are, say, roaring 40s, 50s and 60s carry the water from northwest to southeast, which mix with Antarctica cold polar currents. That why in South Hemisphere ocean there is no subpolar gyre. So this is about the currents of Atlantic Ocean, and you will write it in two paragraphs. One, the current of North Atlantic Ocean and the currents of South Atlantic Ocean.